element modeling of soils on planet Mars, because she's involved in the Mars Exploration Rover mission with Mark Hopkins and a few others, trying to simulate the mobility of the Mars Exploration rovers with discrete element modeling, and using that approach to also infer some of the soil physical properties. Thank you. Go ahead.
Thank you, Lutz. Forgive me if I'm a little scattered. Like you said, I'm totally switching gears here, so I'll do the best I can to remember my train of thought here. This is just a quick snapshot of some of our graphics produced from our discrete element method model of the wheel in soil bed. I'll talk more about this going on. Again, this is work with my colleague Mark Hopkins at Krell and partners that we have at Cornell and others at NASA. So what are we doing? We're working to use the rovers for in-situ characterization of surface changes and soil geotechnical properties. Now, the MARE rovers were never intended to infer any soil geotechnical properties. They were intended to scuff or trench, remove soil from the surface, and then do imagery analysis of the soil they found below, or any kinds of analysis of the soil below. So this is kind of one of those added value science and engineering that we try and do, even though it's not the intended goal of the science mission. So what we want to do is recreate scuff tests from Mars using our DEM model, and then take that soil that we think best replicates that scuff, and using another DEM tool, so we have the wheel tool, we also have a triaxial cell tool that do simulations and try and resolve the soil strength in the area tested. What's our motivation? I think a lot of people have talked about this, and it's probably pretty clear. We can have the right gravity when we do a simulation versus physical experiments in the lab. The cost is much cheaper. It would be a tool for mobility analysis prior to and during a mission, but also allow us to do simulations and comparisons of proposed wheels and tools in extraterrestrial soils or simulants prior to flight. One big thing here, big plug for Rob Sullivan at Cornell. He has been a big help with this work as far as supplying in situ data. And two things I want to point you to are a paper by him recently, him and quite a few others actually, in Journal of Geophysical Research earlier this year, as well as a great image library they have at Cornell dedicated to Mars imagery. Free to use, definitely check it out, it's a good reference. So we got a little introduction to, or a big introduction actually, to the Mars Exploration rovers from Ray Arvidsson the other day. And what I'm going to talk to you about are tests done by the rover Opportunity. It's the rover that's still going today. And this isn't a complete track. I'm sorry, these come out a lot darker on the screen. This isn't a complete track of Opportunity, but this does show us the location of the two tests I'm going to talk about. Sol 371 was in February of 2005. And just after it passed Endurance Crater. And then more than a year later, Sol 878, and that was July of 2006. And I don't know if you can tell the scale very well on the bottom right, but that's 800 meter scale. So we all know these things aren't moving at lightning speed, especially if they're stopping and doing tests in between. So this is another picture, we've seen others, of the rover itself. Like I said, the goal of the mission was not to infer geotechnical properties of the soil. So you see a lot of different instruments. I think he talked about the RAT the other day, which I can't remember what that is, the rock abrasion tool, lots of cameras, lots of different equipment on here, but not related to inferring geotechnical properties.